Again, good morning to everyone. I am Mel Alipio from De La Salle University, currently an associate professor at the Department of Electronics and Computer Engineering. Now, let me begin with the outline of this presentation. So I'll be discussing the following: artificial intelligence, uh, common applications, the workflow that we are using in building our models using AI, and then we'll move on to a more specific type of AI, which is machine learning, and then the respective workflow. And then I will also give you some insights on the possible application and some learning algorithms that are currently in use nowadays. Finally, how these technologies, AI and ML, can be used to optimize and better manage your Open RAN technology or platform. So intelligence and learning. Now, let me just give you a brief background of AI. Basically, it is a simulation of intelligent human behavior. So mimicking what human can basically think. Now, in computer, or it's a computer or system designed to perceive its environment, understand its behavior, and take action. I think this is the most uh, useful part of implementing systems using AI, or we can also say AI-driven approach, because it becomes more proactive rather than reactive. Most of our systems po kasi before are rule-based. So there are only specific rules that your machine needs to follow, then do the corresponding reaction based on that rule. But nowadays, we are already looking at how previous data or how historical data behaves, or what is the trend behind this data. And from that, we are taking useful insight out of these data. And we are talking about huge amount of data here. So they call it big data, and that actually leads towards big data analytics. So there's an action uh, upon identifying a behavior from your model. So your system is becoming more proactive rather than a reactive system. So there are already a lot of applications. I suppose you are already familiar with self-driving cars. Basically, these are AI driven systems integrating algorithms such as machine learning or deep learning into complex environments that enable automation. So the automation is based on the generated classification or prediction of your AI model. So that therefore, it is more, as I mentioned earlier, proactive rather than a reactive approach. Now, AI is estimated to create 13 trillion in economic value worldwide by 2030. This is in addition to the fact that the number of devices is also increasing exponentially. So if you will notice, we are already in a ubiquitous system wherein a single person actually owns several devices. Unlike before, that when the first computer was invented, there are multiple persons that actually controlling the computer, because the computer before was like a huge room, ganun po kalaki yung ano, no, yung size ng computer before. And then dumating yung time na naging 1:1, okay? So one computer or one device being controlled by one person. And then right now, what is happening is it becomes ubiquitous. So a person can control multiple devices. Now, because of this, the requirement in terms of computing also increases. So that's why they see, or they foresee in the future, that through a proactive approach implementing AI, it can basically increase the economic value or the economic impact of of various systems. Now, AI is transforming engineering is nearly every industry and application area. Um, in the Philippines, there are already a lot of industry, uh, especially the large industries who are already integrating AI onto their processes. Now, beyond automated driving, AI is also used in models that predict machine failure, indicating when they will require maintenance. It can also be applied to health and sensor analytics, such as, for example, patient monitoring systems and robotic systems that learn and improve directly from experience. So basically, there are a lot of AI application nowadays. So I cannot, name all of them here because we have a limited amount of time. But this is to simply emphasize that AI is here, okay? So it's inevitable and that it will grow exponentially proportional to the number of device that we are currently using. Now, it was first coined in 1950, the capability of a machine to imitate intelligent human behavior. And it gets more interesting when the machine cannot just imitate but exceed human performance. Well, it's possible po, no, that even if AI was made by a human, it can exceed the human intelligence. Okay. Well, it gives us the opportunity to upload repetitive tasks or even to get computers to do jobs more safely and efficiently, mainly because it lessens human error. I think that's the one of the benefits of automating the system or making the system smart using AI-driven approach. When people think of AI today, almost similar to or almost synonymous to machine learning. But later on, we'll try to further discuss the differentiation between the two, okay? AI and machine learning. Now, as I mentioned earlier, AI is more of a proactive approach. So it's not like the traditional way of automating system using rule-based approach. Rule-based meaning the use of traditional programming wherein we write a program and then process the data to produce a desired output. So that's how we develop our codes or programming codes. But with machine learning, this is totally the opposite thing. Okay. So in machine learning, you feed in data and the desired output. So basically, you just need an input and an output. So I know all of us here are technical people. Well, most of us, if not all, are technical people, either coming from engineering or computer science or IT. We are familiar with IPO or input process output. Now, in our traditional programming, we normally have the input and then we develop or design the process based on our required output. So that's the flow. Okay. But with machine learning, it's totally the opposite thing because when you build a model or an instruction to automate your system, you simply need an input and an output. Then your machine learning will be the one responsible in generating the instructions or the sequence of instructions for you, or basically the process. So it's very convenient when it comes to the programmers. Now, machine learning programs or models are largely black boxes. Okay? Now, they can generate the desired output, but they aren't composed of sequence of operation like traditional program or algorithm, mainly because it is based from probability and statistics. Okay, so later on, I'll try to provide more information on how these learning algorithms work. Now, there's a lot of excitement today when it comes to machine learning, specifically a subset of machine learning, which is deep learning. Okay. Now, what's deep learning? It is a type of machine learning that is called neural networks. So it uses the concept of neurons. So literally, Like your neurons in your brain are actually connected to each other, and that these neurons are the one responsible for reacting to whatever stimuli our body is experiencing. So for our case, our skin is the largest, well, organ, and that there is a certain layer of our skin that is the one responsible for creating vibration whenever there is a reaction, or let's say a force applied to it, or to our skin. So that layer will create a vibration and then send the signal to our brains via this neuron. So the more neurons being created, the more complicated would be your calculations or your stimulations. Now, deep means the number of layers. So the more layers, the deeper the network. And deep learning networks are very useful when it comes to image processing. So, well, most of applications that involve image processing, uh, they prefer to use neural networks as their learning algorithm. Now, one key advantage of deep learning is that it removes the need for manual processing steps and extensive domains knowledge required for other techniques. So later on, I'll show you the whole family of AI, machine learning and deep learning algorithms. Now, this one is to give you like a visualization on how these three are related to each other. So all deep learnings are machine learning, and that all machine learning are artificial intelligence. Okay, so specifically, neural networks are deep learning techniques. So neural networks are machine learning that is mainly for deep learning platforms or deep learning techniques. Now, let me give you more examples here. This one is the use of machine learning in detecting snack food crispiness. So, one scientist here developed a repeatable process for determining the crispiness of a snack food. I think it's very common naman siguro po that whenever we are eating um, chips or snack, the reference or our baseline for us to know if it is still on its optimum freshness or optimum condition is the sound. So if we will be biting the chip and then meron pa rin siyang cracking, or the usual crispiness sound that we hear once we bite on our chips. That's the indication that it is still on it's still in a good condition. So ibig sabihin hindi pa po siya hindi pa siya like hindi pa sira yung chip mo. So and this application basically detects the crispiness of the food. So other that's the scientists here tried to develop physical models of the snack, but eventually it didn't work. Other scientists had used signal processing to analyze the sound of crunching snacks, but nobody could develop a process that could detect differences between perfectly fresh and slightly stale. Okay, so this is actually one of the challenges in developing systems using machine learning. It is almost trial and error process. So it doesn't mean the first time you employ your model, you will get your expected results right away. So it takes some time to build the most accurate model for your application. So almost trial and error process. So along the way, you identify what to improve or what to revise or what to tweak depending on, again, your application. Later on, I'll be discussing to you the whole workflow process of AI and machine learning. So again, this is one application where in machine learning can be used to classify basically the crispiness of your snack food. Another one is an efficient tunnel excavation. So this one is a Japanese company, the Obayashi Corporation, which uh, uses an excavation technique called New Austrian Tunneling Method. And through this technique or through this approach, the geologists monitor the strength of tunnel face as excavation progresses, assessing metrics such as spacing between fractures. I think that's the problem when it comes to building structure. Before you actually plan the structure itself, you have to assess first the ground. So you have to assess whether there are unnecessary objects underground. So before you build the structure. So basically you will use images or even resistivity measurement of the ground for you to collect enough data and use that data to build a model to identify whether the ground is okay for structuring or building a structure over it, or maybe a tunnel within the ground. And that it will be very much useful in terms of time and allocation of labor on your construction management. Now, of course, there are still several limitations when it comes to this excavation or AI-driven excavation process. It can take hours to analyze on one site. Because of the complexity of the input data, such as images, yun yung nagiging downside, ano? It will take some time before you generate the model. Mainly because malaki yung load mo malaki yung input load mo. So, analysis can only be performed occasionally. Now, in addition to that, there is a shortage of geologists skilled in this technique. Because at the end of the day, it's still the expert who is knowledgeable whether the output of the model is correct or not. So it doesn't mean that we employ AI, i-disregard na po natin yung mga experts, ano. We still need them in order for us to verify the results of our model. Now, another area where AI is being optimized in terms of utilization is in agriculture. So smart and precision agriculture, specifically in harvesting. Now, there is a case in New Holland, massive FR9000 series forage harvesters that are capable of harvesting different crops of more than 3,000 tons per hour while cutting the crop in pieces as short as 4 millimeters. So there is already an accuracy on it. Ano? In addition to steering and maintaining an optimal speed, harvester operators must direct the crop flow into a trailer and monitor its field level. So obviously wala na po tayo dito like manual process, everything is being automated. Of course, with the integration of robotics. Okay? Now, the need to focus on driving and filling tasks simultaneously makes a complex job even more difficult. So, there are actually more processes that can be automated in an agricultural system using AI, not just the harvesting, but even the growing process of your crops. So you can also integrate AI on that. Now, this is the workflow process of the automating agricultural harvester for the filling operation. After they harvest enough amount of crops, they will put it in a storage, and then the system will basically identify whether the storage is already filled or not. So this is in a combination of sensors and computer images or camera images. So you have like a multi-dimensional input here, ano? Most of the time kasi it is always sensors, but Nowadays, computer vision, machine vision through your camera images are also becoming very much useful because of course sensors have limitations. So there is already a good integration between these two sensors and camera images. So as I've mentioned, from your camera, that would be, or the images from your 3D cameras will be transmitted onto your computer vision server or control algorithm server. And then if there is a corresponding actuation, like for example, you are to collect via pick and place robotic arm the crack from the field, then there will be a feedback or closed loop mechanism here. So through your, of course, vehicle display controller, the user can, visualize and have a good interface whether what is the current condition of your crops. It can also be the number of harvested crops, or it can also be the yield, and so on and so forth. So basically increasing the productivity of agricultural farming. Other common applications are, of course, robotics and autonomous systems, industrial automation, predictive maintenance, patient monitoring, electricity use forecasting, and automated driving. So these are just some of the or the many possible applications of AI. Now, just to give you an idea, this is the general artificial intelligence workflow process. So we start with accessing the data. These data can come from sensors or even your historical files or databases or images and so on. And then after which you perform AI modeling. That's the time you analyze your data, perform some exploration and pre-processing. System design, you start developing the model through the algorithms or available learning algorithms. And of course, you have to do some test on whether the model is up to the performance or your required performance. And then finally, you deploy it. Okay. Most of the time, our models are being deployed on traditional mainframe computers. But eventually, or that is before, and then eventually, when embedded system came, AI is already also integrated on these platforms because when we are talking about real-time applications, embedded system is a very good candidate solution, and that performing or deploying your AI onto your edge will basically give you almost near real-time results rather than deploying it to your mainframe or cloud servers. So let's try to discuss each of these in detail. Now, when we say data preparation, it has something to do with taking raw data and making it useful for an accurate, efficient, and meaningful model, which is, I believe, the critical step here. Because your AI model, the capability of your AI model depends on the quality of your data set. That's it. If you have a very poor, unorganized data set, that it basically affects the performance of your AI model. So we have to put more effort on data preparation actually. Okay. Now, it requires domain expertise, such as experience in speech or audio signals, if that is multimedia data, or navigation and sensor fusion, or even image and video processing, radar, and LiDAR. AI also involves contiguous amounts of data, yet labeling data and images tedious and time-consuming. As I've mentioned, this is the part of the workflow where we spend most of the time. So ito po yung pinaka-tedious and critical actually. So again, as I've mentioned nga po earlier, the quality or the accuracy of your AI model depends on the quality of your dataset or your input dataset. So therefore, we have to make sure that our data is well prepared. Now, After we prepare our data, we now move on to the modeling part. So the modeling is simply feeding your input data set onto your learning models. And then your learning model will be building some algorithms, equations, and that from that equation, it will generate a hypothesis on how it will generate your desired output. Remember, the only thing that we need here is your input and your output. Okay? So, based on your input and your desired output, your model will create an algorithm or an expression or equations that will translate classification or predictions of these desired output based from the trends or behavior of your input. Okay? Now, dito po papasok yung ating machine learning and deep learning models. Okay? Now, there are a lot of platforms that we can use in building our AI models. These are the most common ones, MATLAB or Matrix Laboratory. We have also PyTorch, and then we do also have TensorFlow. TensorFlow is Google, ano? But aside from this, we have also other open source platforms like scikit-learn, and more. So ang dami po nating ano no, ang dami po nating pwedeng gamitin actually in building our models, because of course may mga platforms din kasi that are not open source, but that definitely can provide you the best algorithms or learning models and visualization, while we can use naman po yung mga open source or free to use platforms, but at the end of the day there are always trade-offs of using these platforms. Now, manage compute complexity with GPU acceleration and scaling to parallel and cloud servers and on-premise data centers. This is also another challenge of implementing your systems using the AI-driven approach. Because of the complexity of building the model, it will consume calculations or even your memory, your hardware memory, and of course, energy from your devices. So this is another aspect of AI. As I mentioned earlier, from a traditional mainframe computers, we are now transporting the modeling down to embedded devices or embedded systems. And these embedded systems are actually constrained in terms of energy, computing, and communication. So it is a challenge nowadays to perform the AI modeling onto these edge devices or edge or embedded devices. So yeah, again, trade-off. Yes, you can have near real-time output or classification or prediction if you are to implement it on your edge or your embedded devices. But on the other hand, will your embedded device accommodate such complexity from this modeling? Okay. And then followed by your system design. So AI model exists within a complete system. Like for example, in automated driving, AI for perception must integrate with algorithms for localization and path planning and controls for braking, acceleration, and turning. So you have your predictions for localization and planning, and then you have your control for the braking, acceleration, and turning. Okay? So this is what I am mentioning earlier, that in AI system, there is always a feedback loop or a closed loop system, wherein after you perform modeling and generate the corresponding output, in this case, what is the exact location of your cars, then there should be a corresponding feedback to perform some actuations. Like for example, controlling your brakes, or maybe how fast you are driving, or maybe the turning. either left or right or going forward. So there's always this closed loop feedback mechanism in our AI-driven systems. And finally, deployment. Models or AI models need to be deployed to CPUs, GPUs, and FPGAs in your final product, whether part of embedded or edge device, or it can also be enterprise systems or cloud. Of course, for enterprise applications or cloud applications, very minimal naman po yung ating issue when it comes to the capacity of our processing. But again, as I mentioned earlier, the challenge here is if we want our models to be deployed in an embedded device. Well, that would be another webinar. No? So yeah, now moving on, AI models running on embedded or edge device provide the quick results, as I mentioned earlier. It basically reduces the delay of any autonomous or intelligent system, mainly because you are not sending your raw data to be processed to your cloud. Okay? Kasi when you transmit everything to cloud and then doon ka pala magpa-perform ng modeling, then it will take some time before it generates the output. If mission critical or if real time yung ating application, then your system might not be able to, you know, keep up with the requirement, diba? With the time requirement. So there has to be some sort of adjustment when it comes to whether deploy my AI model onto my embedded device or my edge device. Edge device means this is the devices that are near to the user, okay? Or to the monitoring field or to the deployment field. And then of course you have your cloud, which is mainly can be accessed via the internet or through your ISPs. So there is, you know, pros and cons when it comes to the deployment of AI, whether it is in edge or it is in the cloud. There is also this technology called fog computing, wherein we deploy our computation or complex computation in between our edge devices and our cloud platform. So we call it fog computing. Now, the deployment process is accelerated when you generate code from your models and target your devices. Using code generation optimization techniques and the hardware optimized libraries, you can tune the code to fit the low power profile required by embedded and edge devices or the high performance needs for enterprise systems and the cloud. Actually, there are already platforms that can translate very complex AI model into something that is light. Light in a sense that it can be accommodated by the constraint characteristic of embedded or edge devices. So for example, we have TensorFlow by Google. They have this version of TensorFlow Lite. The thing about TensorFlow Lite is that it will convert the complex AI model to a more like simpler implementation that can be accommodated by your edge device. Well, one example of an edge device would be your mobile phones, right? So yung mga mobile phones natin, it actually performs some AI modeling. But how complex it is, coming from like the original form of the model, it can actually now be converted to a lighter version or to a simpler version. Okay, so that is another emerging technology nowadays, when it comes to edge computing. Now, let's proceed to a specific type of AI, which is machine learning. So machine learning teaches computers to do what comes naturally to humans and animals. And that is basically learning from experience. So I think the keyword here when it comes to machine learning is that it is based on historical trend. Okay? I hope you get an idea there, ano? We use machine learning if we want to look at a historical data and then maybe take an insight, a useful insight out of that historical data. So it's like looking at the behavior of that historical data. That if that's your idea, then machine learning is the best platform to use. Okay? Now, machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. Okay? Because as I mentioned earlier, when we do some equations, that is simply a reactive approach, okay? Or a rule-based approach. So for machine learning, we are not relying on these rules or these predetermined equations, but mainly only on the given data set or the given input data set and whatever our desired output, okay? Now, the algorithms adaptedly improve their performance as the number of samples available for learning increases. Again, aside from the quality of your data, we are also looking at the quantity of your data. So as we've mentioned here, the more instances or the more samples you feed into your learning model, the higher or the better will be the accuracy of your prediction or your classification. Okay? So, again, it is always based on your data set, on your available data set. Now, more data, more questions, better answer. That is our tagline when it comes to machine learning. So we have, again, several real-world applications here that involves big data analytics, and that machine learning has become particularly important in solving such areas such as computational finance for credit scoring and algorithmic trading. Very common po ito, no, sa mga very active when it comes to anything related to stocks. Okay. Image processing, computer vision, face recognition, motion detection, object detection. So mostly images. Computational biology for, let's say, tumor detection, drug discovery, DNA sequencing. Now, another would be energy production for price and load forecasting, automotive, aerospace, manufacturing for predictive maintenance, and I think this is another common application nowadays, natural language processing. Siguro po yung pinaka, well, familiar kayo or medyo malapit po dyan, ano, yung mga chatbot. So yung po mga sumasagot po dun sa mga messenger or any like messaging based platform na automatic based on your input statements. Those are actually NLPs or natural language processing. NLP is also being used for yung mga text translations, and then yung mga dialect preservations. If you're familiar po, no, we have a lot of dialects here in the Philippines, and not all of them are still being used nowadays. Yung iba nga po endemic na. So through NLP, actually we can preserve these dialects. Now, how machine learning works? So it uses two types of techniques. Generally, we have supervised learning and unsupervised learning. Now, what is the difference between these two? So the use of supervised and unsupervised learning is based on the available input data. So if you have an input data that is labeled in a sense that you know what is the output from this input. So let's say, for example, you have an input features of a flower. So let's say that flower has features on the sepal width, sepal length. Sepal po is the if medyo po, no. Sepal is yung nasa ilalim po ng pinaka-flower. So yung parang maliit po doon na na portion yung leaf niya. That is sepal. And then you also have information about the petal width and petal length. That would be your input features. And that, given that input feature, you know what is the variety of that flower. So that is what we mean by labeled data set. So you have input feature, and that you know what is the corresponding output based on that input feature. Or let's say, for example, you have the price or I mean the size of the house. And then you also have the information about the number of bedrooms of the house. So given the price of the house, the size of the house and the number of bedrooms of the house, you know what is the corresponding price of that house. So if that's your data set, then it is called labeled data set. So if that is your available data set, then you use supervised learning. Okay? Otherwise, if you have a data set that is unlabeled, meaning you only have the input features, but you don't know what is the corresponding label for each of these features. So for that case, you use unsupervised learning. So basically, the selection whether to use supervised learning or unsupervised learning depends on the data set or the available data set that you have. If you have a labeled data set, then you use supervised learning. If you have unlabeled data set, then you use unsupervised learning. Now, under supervised learning, there is two main algorithms or learning algorithms. So we have regression. I think you're also very familiar with this one, the regression that was taught to us during our statistics and probability course in high school or maybe during our undergraduate years, that is actually a machine learning model or algorithm. The simplest linear regression is actually a machine learning algorithm. Okay? So, but of course, aside from linear regression, we have logistic regression. And then the other type of supervised learning is classification. Okay? What's the difference between the two? Regression basically classifies numerical or continuous data, while classification generates or predicts discrete data, okay, or categorical data. And then we also have clustering for unsupervised learning. So we only have one approach under unsupervised learning, which is clustering. But I think aside from clustering, there is also new emerging learning models like anomaly detection for datasets that are unlabeled. So as I mentioned earlier, for classification techniques, this one for predicting discrete responses, like for example, if an email is genuine or spam, or maybe if a tumor is cancerous or benign. So it's discrete, it is categorical. Okay? While for regression, if you are to predict continuous responses, like for example, temperature, okay, or fluctuation in the electricity, and so on. For unsupervised, again, we have clustering, and it is used for exploratory data analysis to find hidden patterns, mainly because your data is unlabeled. So from unlabeled data, the clustering method will basically group them or cluster them based on the characteristic of these input features. Okay? Now, how do we decide which algorithm to use? So from our machine learning tree here, we have supervised and supervised. Under supervised, we have classification. Under classification, we have support vector machine, discriminant analysis, naive Bayes, nearest neighbor. For regression, we have linear regression, SVR, and SAM, decision tree, neural networks. That's where deep learning falls. And then for clustering, we have k-means, hierarchical, Gaussian, neural networks also, and hidden Markov model. So when should you use machine learning? If you have handwritten rules and equations that are too complex, rules of a task that are constantly changing, so be very active, okay, yung rules mo. And the nature of data keeps on changing and the program needs to adapt, okay? That's the time we use machine learning. Now, what are the possible challenges? Of course, data comes in all shapes and sizes. It has something to do with our data pre-processing. Pre-processing your data might require specialized knowledge and tools, and that it takes time to find the best model to fit the data. As I've mentioned, AI machine learning workflow is almost trial and error process. Okay? So questions to consider before you start. So of course, what kind of data are you working with? What insights do you want to get from it? And how and where will those insights be applied? So these are just three initial questions that you ask yourself before you actually choose what learning model that you will use for your application. So for machine learning, we have the following workflow. This is very similar with AI. So of course, you start accessing your your data, and then perform some pre-processing, derive features using pre-processed data. Number 2 and number 3 steps are the most time-consuming part of building your machine learning model. And then train models using features that you have derived from the previous step. Iterate to find the best model. That's why I'm telling you earlier, it's a trial and error process. Because again, in one pass, you may not be able to get the best result or the best or the most accurate model. So therefore, you have to, repeat it again or iterate the process again. Again, you finally arrive on the best model performance. Once you get onto that point, then that's the time you deploy your model onto your system, whether it is in your mobile phone or your embedded devices or wearable devices and so on and so forth. So maybe I'll just go through each of these steps, but basically these are the same with what we have discussed earlier in the AI workflow. I have here a specific specific use case, which is building an app for monitoring your some of your vital signs using 3 axial sensors from your phone, accelerometer and gyroscope. So particularly, the activities are walking, standing, running, climbing, and stairs. So you have the phone as your data collector, and then using the sensors embedded on your phone, we collect this data, and this data we want to predict, this is your output, whether the man is or the user is sitting or standing or running or lying down or climbing stairs. Okay, so your input is the information from accelerometer and gyroscope, and your output would be whether the user is in a walking position or walking activity, standing activity, running activity, climbing stairs, or lying down. So we know this, and then we also have this information. So we will building the process using machine learning. Okay, so that's the idea. So the first step, collect the data. Okay, so using your mobile phone, and then pre-process this data. Pre-processing involves a lot of steps, like for example, identifying possible outliers, possible loopholes, because yung sensors kasi natin, they are not optimum most of the time. So kapag, let's say for example, nag-deplete yung energy nung source ng sensor mo, so possible na maapektuhan or it will affect the data that it is collecting and transmitting. So you have to perform some pre-processing. Another one is the value of your data set. So if masyadong malayo yung mga values from each other, you may want to perform some normalization for you to converge the values of your input data set. So again, this part actually involves a lot of steps, such as aside from the normalization and scaling, it will also involve you some feature engineering and feature selection, whether you will use all of the available input features or just some of them. Now, after that, we derive these features, or as I mentioned earlier, feature engineering or feature extraction, which is one of the most important parts of machine learning. It turns raw data into information that a machine learning algorithm can use. Okay, so as I mentioned, it is not always necessary to include all the input features in generating or building your model. Sometimes it is useful to select some of the input features. Okay, so again, it is also a trial and error process. So depending on the data type that you have, if you have sensor data, image or video or transactional data, you perform the specific techniques for each of the respective type of data. And then after which, you start building your model. So this is the time you select which of the available learning models you will use in building your predictive or your classification model. So in this case, our example used decision tree. And then we also have another one, which is KNN. And then I think there is a comparison between the two here. And that KNN achieve a better result, which is 99%. And then from there, you may want to improve further your model by performing some more techniques like correlation matrix, principal component analysis, and sequential feature reduction. And then it may include more complexity, like use model combination and more data sources. As I've mentioned, the more data that you include, or the more samples that you include in your data set, the more accurate your model will be. Now, going to the intelligence and learning in Open RAN. So what would be the possible application of AI and machine learning in an Open RAN environment? So basically, the sixth and or the fifth and the sixth cellular networks technology will basically accelerate the transition from inflexible and monolithic networks to agile disaggregated architectures based on softwareization and virtualization. Okay, so what you can see here is the possible implementation of AI and ML, particularly in the RAN intelligent controller, or RIC. So the AI and ML in Open RAN usually is being deployed at the cloud. Okay, so that's why it's here. Now, I know you are familiar with some of the like abbreviations here, so I will not anymore go onto details with this one. But well, of course, you have your control unit, your distributed unit, and your radio unit. So CU, DU, and RU, and that your RAN intelligent controller has two components. You have your non-real time and your near real time RIC. Okay, so basically your non-real time performs operation with time granularity higher than 1 second. So hindi siya delay sensitive. Okay, while on the other hand, near real time RIC handles procedures at time scale above 10 milliseconds. Okay, whose third-party application like the X app. Okay, so through the interfaces like A1 and O1, our cloud is able to collect enough data that will be used by your AI and ML. Okay, and that data will be coming from either your edge, or it can also be coming from your end device, which is in case your cell site. Okay, so while ORAN architectural vision is gaining momentum among researchers, the challenges of implementing it for data-driven, open, programmable, virtualized next-generation networks are still largely to deal with. Important architectural questions are yet to be answered, actually. So this is still an open research, an emerging research. Well, I highly encourage you, especially for those who are doing research here, either in the academy or industry, to explore more on this topic. Now, what you can see here now is the intelligence embedded at different layers and entities of our disaggregated cellular network together with challenges and limitations of doing so. So, from the cloud, you have your non-real time time scale of above 1 second. And the control and learning objective that you can implement here using your AI or ML is the policies, models, and slicing. At this particular layer, you have, well, more than 1,000 of devices. So the major challenge here would be the orchestration of very many real-time RIC or RICs, and the other components of your RAN, which is your CUs, DUs, and RUs. Now, going towards the edge of your network, then we have our near real-time timescales, which is above 10 to 10,000 milliseconds. The control or learning objectives that we can basically apply learning, or AI and machine learning, are user session management, medium access management, radio management, such as resource scheduling, beamforming, And finally, your downlink and uplink management, particularly modulation, interference, blockage detection. Okay. So, of course, each of these control and learning objectives might have other challenges and limitations that you may want to explore later on if you want to do some research in this particular field. Now, there is a use case implemented in Colosseum in Italy, in Rome, Italy, wherein they deploy the traffic generator using these intercell sites. They use 4, and then I believe there are 4 base stations and 40 UEs for the data collection process. And then from that data, they use it to build scheduling techniques using AI. Okay, and that scheduling can be seen from this workflow. So you can see here clearly the feedback mechanism. So from the data collection in your base station, you can actually identify what are the possible input features that you will use, such as for scheduling, slicing, and data collection module. And then from that, you build your AI. That's the next step, AI ML model design. Of course, you perform training and testing of your model. And then once you get your desired accuracy, you now deploy it to your X app. Okay, so X app is actually another platform used for Open Run GYM or GYM. And then from that, we fine-tune our model until such time we achieve the most suitable one that can give us the optimum performance in terms of managing our cellular network. And then finally, the last one is to perform RAN and control and inference. So if your data changes over time or over period of time, how you will control your run will also change or will also adapt. So that's the good thing about integrating data-driven approach or AI or ML-driven approach to Open Run. So it makes it actually improves the openness. It's more virtualized, and it is better. It will result to better management. Okay, so basically that's it for this one. I know we have I have exceeded the time, but there's a lot more concepts to be discussed here because this one is an emerging research. So there's a lot of rooms to be explored. There's a lot of opportunity to work on this particular field in the area of Open RAN. So with that, thank you for listening, and